All right, guys. So today we are going to talk about congruence and similarity, what the difference is between the two, and how the transformations will either give us a shape that is congruent or similar after we perform that transformation. So first, let's talk about congruence here. I'm on page 23 in your books. This is learning goal 1.1G. And it says here for our definition of congruence that two figures are congruent if they have the same shape, same size, same angles, and same side lengths. So we'll talk about some differences between that and similarity a little bit later on. But the transformations that give us two figures that are congruent are going to be those first three that we talked about. The first one here is the first one that we talked about, translations. So we're going to put translations down there. Rotations and reflections. I'll put reflections first. All give us congruent shapes, meaning they're the same shape, same size, same angles, and same side lengths. Okay, and you can see some examples here. We've got these two triangles here that one was reflected onto the other. And you can see my angle stayed the same. These little dashes here are saying that those side lengths are the same. So those reflected sides, if you notice for all three of them, since they have the same dash marks, that means that they're the same measure. And the angles all stayed the same as well. Okay, so reflections, rotations, and translations will give us congruent shapes. And you can see the translation example right here for triangle IKN. So you can see we move it there. Those side lengths don't change. The area of the triangle is not going to change, and those angles don't change at all either. And that works for the reflection, which we already talked about. And then we have this quadrilateral down here that's showing you that even if you rotate it, side lengths stay the same, area stays the same, angle measures stay the same, and the shape itself is the same. All right, so if you look at the next page, we'll talk about similarity. Now, similarity is a little bit different. Our definition here says two figures are similar if they have the same shape, the same angles, but they are not the same size and not the same side length. However, the size and the side lengths are going to be proportional. So what we mean by that is the area and the side lengths are going to be proportional. And you can see if I set up a little proportion here, I can tell this shape here is my original shape, and it got dilated, it got enlarged, right? So I've got this larger shape. Well, what side corresponds to that side that has an side length of 4? It would be this 8, right? And same thing here. This 1 corresponds with this side length here. That's a 2. I could set up a proportion there, and that proportion, 4 goes to 8, is equal to where 1 goes to 2. And we know that. We know 4/8 is the same thing as 1/2. That's a proportion. So those side lengths will be proportional. If I were to measure the area would be proportional as well. The same thing is true for this rectangle, right? 10 goes to 15, and 16 goes to 24. Now those two fractions, if I set up those proportions, 10 goes to 15 and 16 goes to 24. Both of those fractions reduce down to, oops, let's erase that. Both of those fractions reduce down to 2/3, right? So they're proportional, they're equal. So that's what we mean by similar. The shape stayed the same. It's a rectangle. It's a rectangle here where we started, and it's a rectangle here where we finished, okay? But the side lengths have to be proportional in order for them to be similar. All right, so we also want to say that two figures are also similar if we do any of those transformations now. So it's not just those first three, it's still translations where we slide, translations, it's still reflections, it's still rotations, but now we can add in this most recent one that we learned, which is dilations. And then there's just an example with those triangles there. You can see the original shape was enlarged, it was dilated, scale factor that was bigger than 1, right? Well, those angles are going to stay the same. The side lengths and the area are going to be proportional. Okay. All right. Here, they want us to go through and just say, number one, what's the transformation? So identify the transformation. But then also, is it going to give us a shape, or is the other shape congruent or similar? Okay. Only translations, reflections, and rotations will give us congruent shapes, right? Dilations are where we get the similar. So here for this first one, I can see I'm going to draw, it doesn't ask me to, but I'm going to draw my line of reflection, right? I can see that this shape is reflected over that line, x equals 1. So I'm going to put first off that it is a reflection. And because it's a reflection, those two shapes are congruent, right? Which means the area and the side lengths are the same, as well as the shape and the angles. Okay, I've got another reflection right here for my next one. Right, that shape was reflected over that line of reflection, y equals 1. And because it's a reflection, those two shapes are congruent. For this next one, my shape was translated, right? It slid down and to the left. So I'm going to put that translation. And then translations also give us congruent shapes. For this next one, I can see it was rotated, right? All of those get rotated around this point E right here. So I'm going to put rotation. And that means it is congruent because it's a rotation. The shape stayed the same, the angles stayed the same, the side lengths stayed the same. And therefore the area would stay the same also. Okay, I've got another rotation here. This one was rotated about the origin, but it's going to give me a shape that's the same size, same side length, same angles. So it's going to be congruent. Now finally we have, I'll shade this in here so we can see it a little bit better, but I have this trapezoid right here, and that got dilated to be this larger trapezoid right here. Okay, so that was a dilation, and remember dilations are the only ones that would give us not congruent. So we're going to go ahead and put similar. And then I can see the same thing happen for these triangles, right? Here's my original triangle. It got much larger, right? It got enlarged, scale factor greater than 1. So that's a dilation. And again, those two shapes are similar. They're not congruent because the side lengths in the area are not the same. They're proportional, but they're not the same. And then last but not least, I have this translation down. So translation. And that gives me two shapes that are congruent. Okay, now we have some practice. It's kind of like what you'll see in your assignment here for this section. We've got translations, we've got reflections, we've got rotations. They all give us two shapes that are the same size, same side length, and the angles are the same, right? Dilations are the one that do not give us the same size. So transformations of congruence, just to refresh and go over that. Translations is the first three that we talked about. Translations, reflections, and rotations. Ignore my horrible handwriting. In these types of transformations, so let's go over this one more time. Okay, in these types of transformations, we have the side lengths that remain the same. We have the area that remains the same. And we have the angle measures that remain the same. Those three things will always remain the same with translations, reflections, and rotations. Okay? The one that is different, the transformation of similarity, dilations. Dilations do not give us the same side lengths or areas. They do give us the same angle measures. Okay, so let's go ahead and put that down. In this type of transformation, side lengths and they don't just change, they have to change proportionately. And if the side lengths are changing proportionally, then we know the area changes proportionally. Right? The only thing that remains the same with dilations is going to be the angle measures. All right. If we look at the next page here, it says now you try. I'll go through it with you though. It says on the set of axes below, Gregory drew a rectangle ABCD. He will transform the rectangle by translating the figure 7 units down and 2 units to the right, and will then reflect the translated rectangle in the x-axis. So he's performing two transformations, right? Translation, because he's going down and to the right, and reflection. So we've got two transformations, and then then it says here for the question, what will the area of the rectangle be after these transformations? Well, we just wrote that on the other page, right? The area doesn't change with those two transformations, right? It won't change with translations, reflections, or rotations. So even if you would have rotated it, the area is not going to change. So all we have to do is find out what this area is. And if I count here, it looks like it's helps if I use the pen. Looks like it's a 4x7 rectangle, which would give us 28 square units. Well, after he does all those transformations, it's still going to be 28 units, 28 square units, right? All right, let's look at the next question. It says triangle ABC is graphed on the set of axes below. Which transformation produces an image that is similar to, but not congruent to triangle ABC? So the only transformation of similarity is, if you said B, dilation, you are correct. Think about what that scale factor means too. Let's do a quick review. If the scale factor is bigger than 1, that means the shape is getting larger, right? So we're going to enlarge that shape. It's only if the scale factor is smaller than 1 that the shape will shrink. And then we just have a couple more questions. On the next page here, number 3, it says in triangle ABC, the measure of angle A is 30 degrees. After a 90-degree clockwise rotation, what will the measurement of angle A be? What will be the measurement of angle A? Well, remember, rotations, and even if it's a dilation, the measurement of the angle will always remain the same with all four of these transformations. So it's still going to be 30 degrees. Okay. And then last but not least, we have question 4 here. It says figure ABCD will be translated 5 units to the left and 7 units down. Which aspects of the original figure will not be preserved in the translated image of ABCD? So let's go through our options here. A says the area of figure ABCD. Is area preserved when we're translating a shape? Yes, it is. Okay, so that can't be our answer. Option B says the length of segment AB. Remember, side lengths are preserved also. So it can't be option B. Option C says the measure of angle D. Well, it doesn't matter what transformation we're doing. The measurement of the angles will stay the same, whether you're translating it, reflecting it, rotating it, or dilating it. So it can't be C. That means our answer has to be D, unless this is a trick question. Option D says the location of point C. Will the location of point C change? Yeah, it will. It's being translated 5 units to the left and 7 units down. So that is the correct answer. All right, so that is what you need to know about congruence and similarity. Your assignments, let me see in my book here, begins on page 29 and includes pages 29 and 30. Make sure you ask your teacher if you have any questions.